Welcome to Organic Chemistry, Lesson 9. This is about IUPAC names, mixed compounds. This is a very important lesson for you to identify the different functional groups and then remember what their suffixes are to identify the name. For example, if you have to arrange this table, the first one, you have the IUPAC name methane, and that has the functional group alkane. So therefore, methane is number 1 alkane. Let's try to do this second one. Propanoic acid. If you see propanoic acid, you should know that we are talking about a carboxylic acid. And if you go and look in your table, you'll see carboxylic acid is at number 4. The next one, 2-chloroethane. Now you should know that if you have a halogen there, this must be a haloalkane, which is number 7. 1-octanol. If you see the ol at the end of the name, you should know that this is an aldehyde. Jy gaan nou daai stukkie met uitsteek. Want ek nou fout gemaak. Okay, if we look at number 4, you have 1-octanol, which means there's an ol at the end of the name, and that must be an aldehyde. Aldehyde is at number 5. Next, we have 3-heptine. If you see ine, you should think triple bond. If you think triple bond, you should think alkane. There you go, number 2. The next one, butanone. If you see one at the end of the name, you should know that we are talking about a ketone, number 3. 3-hexene. If you see ene at the end of the name, you should know that we are talking about an alkene, therefore number 8. And then 1-hexanol. If you see an ol at the end of the name, you should immediately think about an alcohol, which is at number 9. And the last one, methyl pentanoate. You should know that if it's OH at the end, we are talking about an ester. And an ester is at number 6. Please go and see if you understand what's going on here by going slowly through the video and checking the names yourself. Example 2. Here you have a structure and then you have to search for the name here. In this structure we have 3 carbons and only single bonds. Therefore this must be an alkane. And if you have 3 carbons, you know propane. And there you have it. Then for number 2, you have again 3 carbons, but now you have a triple bond. So it will again be prop, but now it needs to be ine at the end to indicate the triple bond. Then for number 3, you can see that there is a carbon double bond oxygen, which is a carbonyl moiety. Now you get 2 carbonyl compounds. The first one is an aldehyde and the second one is a ketone. The aldehyde is at the end of the chain and the ketone is in the middle of the chain. If you look at this molecule, you can see that the carbonyl carbon is in the middle of the carbon chain. Therefore, this must be a ketone. It's got 3 carbons, therefore, propanone. For the next one, you have a carbon double bond oxygen bonded to an OH group, which means carboxylic acid. You've got 3 carbons, therefore, propanoic acid. And then this one, you have a halogen there with 3 carbons, so 2-iodopropane. Here, you have a carbonyl carbon, and it almost looks like a carboxylic acid, but instead of an OH group here, you have an oxygen with another carbon chain. Therefore, this must be an ester. Now remember how to name your ester. You cut your molecule in 2 and you look first at what is bonded to the oxygen part, which is now 2 carbons, therefore ethyl. And now you number your carbonyl part, and your carbonyl carbon is always number 1, so methanoate. There you go. And then for the next one, you have 3 carbons, but now you have a double bond. And a double bond should immediately let you think about ene. Therefore, propene. And then for the last one, you have 3 carbons, and this carbon number 1 is a carbonyl carbon, and it's at the end of the chain. Therefore, this must be an aldehyde, propanol. Example 3. Write down the letter representing the compound which is an aldehyde. Now let's go and look here. A, B, C, D, E or F should now be an aldehyde. Here you have an alkene, so it's not that one. B, you have an alcohol. C, you have an ester. D is just a usual alkane. Here you have a carbonyl carbon at the end of the chain. So the answer should be E. Why not F? Because here the carbonyl carbon is in the middle of the chain. And an aldehyde's carbonyl carbon must be at the end of the chain. So the correct answer is E. Now for the next one. Which compound has the general formula CnH2n? Now you should know your general formulas, and CnH2n is an alkene or a cycloalkane. You don't have cyclic molecules, therefore alkene is at number A, so the answer should be A. Then for the next part, which of these compounds is unsaturated? What does unsaturated mean again? That means it needs a double bond or a triple bond. An alkene's got a double bond, so the correct answer should be A. Then for the next compound, they want a ketone. Now, when we looked for the aldehyde, we saw the ketone at number F. It's got a carbonyl carbon in the middle of the chain. Therefore, a ketone is at number F. And now, you have to look for a hydrocarbon. What does hydrocarbon means? It's only got hydrogens and carbons. Therefore, number D is the correct answer. Example 4. Here again, you have to identify these molecules from the table above. Now the first one, we want an alkyne. Alkyne means triple bond. So let's see. Number A, it's got a triple bond, so the answer must be A. Now you have to identify 2 compounds that are structural isomers of each other. What does structural isomers mean again? They need to have the same molecular formula, therefore the same amount of carbons, the same amount of hydrogens and the same amount of oxygens. So let's see. At number A, you have 1, 2, 3, 4, 5 carbons. At number C, you have 1, 2, 3, 4, 5 carbons, but the amount of hydrogens differ. B's got 5 carbons and an oxygen. F's got 1, 2, 3, 4, 5 carbons and 2 oxygens. E's got 1, 2, 3, 4, 5 carbons and 1 oxygen. And then pentanoic acid you have to draw for yourself. And there you have it, pentanoic acid. Let's count. 1, 2, 3, 4, 5 carbons with 2 oxygens and a hydrogen. Let's count the carbons at F. 1, 2, 3, 4, 5 carbons with 2 oxygens and the same amount of hydrogens. Now it must be D and F that is structural isomers. It might also have been B and E, but the amount of hydrogens will differ there. Go and count them and make sure. A compound containing a carboxyl group. A carboxyl group is only found in a carboxylic acid. Therefore, number D. And then we have to look for an aldehyde, which is number E. You have a carbonyl carbon at the end of the chain. And now we have to find an alcohol. Therefore, you have to look for an OH group. And here in number B, you have a carbon chain with an OH group. There you go, B. Thank you.